Hi YouTubers. Here is a section of commercially available fiberglass mat. I purchased this 1 yard from a vendor on Amazon. It's relatively inexpensive, and such material has been used in battery and supercap applications, for example as a separator. And it's non-conductive and has very good properties, particularly with electrolytes, which contain acids like phosphoric acid. What I did was I took a couple of sections of the fiberglass mat, and I dip coated in a warm solution of Agar Agar, 1% mass volume. Bring the water up to about, with the Agar Agar, about 90 degrees Celsius. Stir until homogeneous. Let it cool down to about 60 degrees Celsius, and pour it into a glass holder, and dip coat the samples of the fiberglass mat before the gel forms. And I turn it over a couple times with forceps, and then let it drip into the glass container, and then I put them on another section of glass and leave them for 24 hours. So I'm hoping that the Agar Agar film can prevent shorts with 2 sections of electrode in a SuperCap. I'm working with graphite electrodes, and this will provide, hopefully, the mat some mechanical firmness for the Agar Agar as an alternative to chemically cross-linking the Agar Agar thin gel with glutaraldehyde. And I'll examine this by scanning electron microscope and look for any pores or areas that weren't coated. And these sections then were placed in this food dehydrator, and I'll leave it for 24 hours to dry it out and seal them in plastic until I need them. And when I go to use a sample of this, a separator and in a SuperCap, I will apply an electrolyte of interest. Could be phosphoric acid, could be a deep eutectic solvent with electrolyte. Right now I'm looking at a DES 1-to-1 mole ratio, 85% phosphoric acid with choline chloride, so liquid at 20 degrees Celsius. So I can coat this with an electrolyte, and the dehydrated gel should swell as it picks up the electrolyte. Trial and error, and then test it out and see if I get a short. And without this type of coat, I do think I would have problems with the aluminum. I think there would be contacts. Now, to compare, here is a sample that I dehydrated 24 hours. There's no aluminum. There's no fiberglass mat. This is simply a Agar Agar gel, which was cross-linked with glutaraldehyde. I have another video describing that. And then bathed in a saturated potassium chloride solution. And I left it overnight and then dehydrated it. It went from about 16.04 grams, the swollen gel, down to 6.07 grams, and that will be vacuum sealed until I need it. And then I could apply water and see if it acts as an electrolyte membrane, and compare it to such work with the fiberglass involved. I'll keep you posted on results, and we're not interested in a supercap that's going to, of course, work for 50 cycles. We want to go up to 500 or 1,000 cycles of charge-discharge and see if we get any shorts occurring. And as I said, I'll be studying this before and after cycles with scanning electron microscope. This glass, fiberglass, definitely can be investigated with scanning electron microscopic imaging. Thanks for watching. We'll keep you posted. Bye for now.